Okay, so this is the unit that I'll be talking about today, the Liftmaster 3800 PLD. The symptom was that the door was opening and closing by itself, and the wall control unit was flashing the red and yellow LEDs as if it was charging, but after it had attained the reset state, that is the yellow LED on and everything working fine, all of a sudden we had the garage door going up and down and the red and yellow LEDs were flashing. I had replaced the wall unit per the issue with leaking capacitors, thanks to Liftmaster, but that did not resolve the issue. So this is the circuit board. I don't know if you can see, but in the area below R4 there's some discoloration where the circuit board was getting too hot, where there's two diodes and 3 transistors. The reason it was getting too hot is that these 330 ohm resistors were too hot to touch. They're 1 watt. They're running almost at 1 watt with 15 volts across them, and they supply the power to the wall unit. So what I first did was I elevated them to get them out of the way, raised them up about 1 inch. Everything went okay for about a day, and then the problem came back. So I then went in and reverse engineered the schematic in this area that was discolored from heat, and found that one of the resistors that's supposed to be around 4.7k was reading 30k, and resulting in 25 volts being supplied open circuit instead of 33 volts to the wall unit. So that resulted in the wall unit not kind of fully charging and giving the red and the yellow LEDs flashing, indicating that there was an issue. And I then added this resistor in parallel, since I didn't want to undo the surface mount resistor, 5k in parallel, and since then everything's been working fantastic. I am going to replace these 330 ohm resistors with 10 watt rating to give some engineering margin, and hopefully they won't get as hot then. That was pretty much what I had to do. I don't know if Liftmaster is aware of the issue, but this unit's obsolete anyway, so it's kind of like a moot point. So this is how it looks once I'd replaced those 330 ohm resistors with 5 watt ones. I think you can see it there. I got them on eBay for $1 each or something. Now if you touch them, they're still warm, but I'm not concerned about it. And I also left them jacked up in the air. You can just see that discolored area again around R4. Left them jacked up in the air, so I think this is going to work good. Just wanted to show you the after picture. I'll save the other resistors. I'm assuming based on their dimensions that they were 1 watt, but they got too hot. So this is my attempt to reverse engineer the circuit board to the schematic. Get a power supply, a full bridge rectifier, resulting in a 35 volt node that feeds this 330 ohm resistor in series with this 330 ohm resistor. They're the ones that were getting hot, and that current path then goes out to the LED beam, safety beam. Now the path that was failing due to the 330 ohm resistors getting hot was this pink path through what I called TA, and out through an 820 ohm resistor out to power the wall unit. So there's two components of this. One is to supply power, and the other one is a bidirectional serial link. So this 200 ohm resistor provides a 0, and this transistor TA turns on, provides the 1 and the power. What I found was that the resistor that turns this on, which was 5K, as a result of getting hot from the 330 ohm resistors, was actually measuring 30K, resulting in this open circuit voltage to the wall control unit reading about 25 volts instead of 33. Once there's a load on it, which is the wall control unit, this node here charges the capacitors up and arrives at around 5.5 volts, keeping the capacitors charged and providing a bidirectional serial link back to the PIC controller. And that's about it for my reverse engineering of the schematic. If anyone has the schematic of the control board for the 3800 PLD Liftmaster, give me a shout, because I'd like to get the whole thing, do a better job of this in the future. Thanks.